Hello, how are you all doing? In this video, we're going to talk about the properties of equality. Let's get started. Although they may seem like very basic properties, and even quite logical to a certain extent, they help us understand why we perform operations the way we do. So it really is important for you to pay attention, because this is truly fundamental. Look, we're going to see three types of properties: the basic properties, the operational properties, and the substitution properties. So come on, let's start with the basic properties. In the basic properties, we have three: the reflexive property, the symmetric property, and the transitive property. We'll start with the reflexive property, which tells me that every number is equal to itself. I know it's very obvious, but that's what the first property we're looking at says. Every number is equal to itself. We can represent this in the following way. Let's say that A stands for any number. The number is equal to itself. For example, 5 is equal to 5 or 3 is equal to 3. Easy, right? Symmetric property. If one number is equal to another number, then the second is equal to the first. This may also seem very logical, but it will really be useful for us. We can represent it in the following way. Let's say that if A is equal to B, then B is equal to A. So, if A is equal to Reuben, which is what I was telling you about, right? If one number is equal to another number, then the second number is equal to the first number. This is what the symmetric property tells us. Don't forget it. An example could be the following. If we have that 8 is equal to x, then x is equal to whom? Well, to 8. This would already be an example then of our symmetric property, transitive property. If a number is equal to a second number, and this second number is equal to a third number, then the first and the third number are equal. We can write this as follows. Let's say if A is equal to B, and it also happens that B is equal to C, then, well, A is equal to, who is it equal to, right? Since A is equal to B, and B at the same time is equal to C, therefore A is equal to C. That's why I was saying, if a first number is equal to a second number, and the second number is equal to a third number, then the first and the third number are equal. For example, if we know that x is equal to y, and we also know that y is equal to 8, then x is equal to 8. Check it carefully, please. Look, we're saying that x is equal to y, but we're also saying that y is equal to 8. So, if this is the case, does it mean that x is equal to 8? Don't forget this. This is what the transitive property talks about. With this, we finish the basic properties. Let's move on to the operational properties. We're going to divide this into two: the additive property and the multiplicative property. Let's start with the additive property. This tells me that if we add or subtract the same amount on both sides of an equation, the equality remains. We'll represent it like this. Let's write it down. If A is equal to B, then A plus C is equal to B plus C, as you can see. If we have, well, an equation, and in this case we add C to both sides of the equation, this equality will be preserved. Let's consider a classic example. All right. Let's suppose that x minus 7 equals 15 in this case. So we have an equation, right? And look at what I'm going to do. Since this property tells me that if A equals B, then I could add a value C to the left side, but if I add it to the left side, then I should also add it to the right side, right? Since it says that if A equals B, then it also means that A plus C equals B plus C. In other words, I can add the same amount to both sides of the equation in this case. So, look at what I'm going to do. I'm going to keep writing x minus 7, What would it be? I'm going to leave a small space and I'm going to keep writing 15, which would be the B. And in this case, I'm going to add to keep the equality, which is what I just did, And it's actually valid because we're following exactly this property, right? We're not doing anything strange, we agree, so here I would finish the example of the property. But I'm going to continue a little bit more. This lets you see where we'll end up and what this can be useful for. Look, here I have x minus 7 plus 7, but minus 7 plus 7 is 0. So those two cancel out, and I'm only left with x on the left side. And on the right side, I have 15 plus 7, and 15 plus 7 is 22. As you can see, here I'm already solving the equation. But in order to solve it, I had to use this property. The multiplicative property is very similar. It states that if we multiply or divide both sides of the equation by a value that is not 0, then the equality is maintained. We can write this in the following way, so let's put it again. If A is equal to B, then A times C is equal to what? Well, B times C. Keep in mind, this doesn't only work for multiplication, it also works for division, just like I mentioned earlier that the additive property works for addition and subtraction. For instance, we could have an example like this. Look, let's say if x divided by 3 equals 6, then I could do the following. Watch, I'll check. Copy x divided by 3, leave a space, then copy the 6 here. In this case, I can multiply both sides of the equation by a value c. In this case, the value c I'm going to choose is 3. So I'm going to multiply the left side by 3. But then should I also multiply the right side by 3? Why am I doing this? Well, because I already know that 3 divided by 3 is equal to 1. Therefore, on the left side, I would only have x times 1, but x times 1 is still x. So, on the left side, I would have x, and on the right side, I would have 6 times 3, which is equal to 18. Again, as you can see, the use of this property, which is the multiplicative property, is allowing me to solve this equation. Pay attention. This is where I'm applying my multiplicative property. With this, we would be finishing with the properties of operation. Let's wrap up with the substitution property. This basically tells me that if two quantities are equal, then one can be substituted for the other in any operation. Look, for example, let's suppose we have the following equation. We have 6 times m plus 3 squared plus, let's put here 7 times m plus 3. And we're going to set this equal to 3. Let's see, if I want to solve this equation, first I need to expand this binomial squared and then multiply by 6. Then, multiply 7 by this binomial. And after that, simplify and then solve the quadratic equation. What would I have left? I could do that, but I can also do something quite interesting. Look, I can say, for example, that x is equal to 3, so I'm going to declare that. If x is equal, not 3x is. So instead of having the operation just as we have it, I'm going to make this substitution. Therefore, I would have 6 times m plus 3 squared. But m plus 3 is x. So I have 6 times x squared plus 7 times who? Well, by m plus 3. But again, m plus 3 is x. So I have 7 times x. And this equals 3. As you can see, this is a binomial. And it's easier to solve, right? Here I could simply move this 3 to the other side, subtracting. So I would have 6x squared plus 7x minus 3 equal to 0. And well, I could find the values for x. Okay, here I would find two values for x. I could do it with the quadratic formula or by factoring. Once I find the x values, I need to plug them in here. Starting with the first type I find. A plus is equal to plus 3, and this is equal to m. Plus 3vi is equal to 33, and this is equal to m3. This is equal to 3 times m plus 3, and this is equal to 3 times m plus 3. And do you need? Alright, well, that's all for today. I hope the video was helpful for you, but most of all, that you enjoyed it. If you liked it, please subscribe to the channel and also check out this complete playlist. Here's the full Mathematical Thinking 2 course for high school. See you next time. Take care and behave. Bye.